Very good evening to everyone who is watching and listening to our presentation, which is the astronomical picture of the day by NASA, as presented by our Astronomical Society of Penang. Okay, so my name is Dr. Chong, as a member of this society, and we have here our presenters, also co-presenters, Dr. Jiwaras Nadaraja. All right, welcome, and also our member, Mr. Tae Yong Lip, also. All right. And because this presentation is hosted by Michael Teo, our member. All right. So I and Yonglin, we are in Penang, where Dr. Jiwarash and Michael are in Ipoh. And because this pictures for March 2024 is selected by our member, Mr. Lai, who is now in Beijing. So we are presenting tonight, 31st of March, 18 pictures. Okay. So now I will start off by presenting the first one. So please let me share my screen. Can you see my screen?
Yes.
Okay. So basically, this is the astronomical picture of the day by NASA. And then it shows since 1995, every day they will post a picture which is from the observatory in the world or amateur astronomers or anywhere related to astronomy. So for 31st March, which is today, let me look at this first. Nice one. It looks like it's a bit too big. Let me reduce the size of the picture. Okay, so I'll repeat the title: Total Solar Eclipse Below the Bottom of the World. So basically, this one is by our Petr Horolek. So in Czechoslovakia, Petr means Peter. So Mr. Peter Horolek from the Czech Republic is a famous amateur astronomer which travels around the world. He's some kind of a astrophotography and ambassador for ESO, European Southern Observatory, and he's from Czechoslovakia, lecturer in the Institute of Physics in Opava in Czechoslovakia. And the acknowledgement is that the information of this eclipse is by our Javier Marie Joubier, kind of IT manager for the French company, a famous guy. So Monsieur Joubier maintains a solar eclipse and lunar eclipse website, very popular. Okay, so basically, to see this eclipse, which is over the Antarctica, he went into a plane. So on the plane, he looked at the sunrise. He's looking at the sunrise in the Antarctica and over the Antarctic Ocean. So this is in the air, in the aeroplane, and you can see the eclipse. So you see here the total eclipse, and the date of the eclipse is 4th of December 2021, 3 years ago. All right. Now remember, December is a southern summer. So it's summertime in December there, and you can see the fully eclipsed sun, and you can see the black dot, which is the moon, and then you have the corona of the sun, and over here you see another airplane. Now I'll try to enlarge the picture here so that you can see that aeroplane. Can you see here the aeroplane here? There's a wingtip of this plane, and far away, flying in parallel formation with this plane is another aeroplane also observing the eclipse. And if you were to look carefully, all right, near to the sun, I enlarge it some more. Okay, it's quite clear to me. I don't know if you can see. There you are, somewhere on the right here is the planet Mercury. So during the total solar eclipse, you can see also the planet Mercury. So you have Peter Horolek from the Czech Republic. He flew around the world to observe this total solar eclipse on 4th of December 2021, and he only published it recently in March. And then this is it. And basically what you see here, so basically what about this kind of cone-shaped thing is the shadow of the umbral shadow of the moon, the full shadow of the moon, left the moon and flew about 500,000 kilometers and hit the Earth's atmosphere. And you see this cone. This is the shadow of the moon. So basically, this aeroplane is under the shadow of the moon. So what is this aeroplane experiencing during the total solar eclipse? It's experiencing moon night, the night of the moon. The shadow of the moon, the full shadow of the moon, left the moon, come about 500,000 kilometers, fall on the Earth, and where is this one? So this is the what they call the total solar eclipse of 4th December 2021. And remember, being in Antarctica in summer, which is 24 hours daytime, the sun does not rise from the below the horizon goes up, because this is close to the South Pole. The sun actually moves parallel to the horizon. So if you were to follow the moon and the sun will move from the left to right, parallel to the horizon, because it's what? 24-hour daylight. So it moves parallel to horizon. And just at that time, you have a total solar eclipse captured by our Mr. Peter Horowitz, the amateur astrophotographer from Czech Republic. Okay. So now I will pass over to the next person, Dr. Jivaraj.
Okay. Hi. All right. Now I'll be presenting on APOD number 28.
Yes.
Now, which will be yes.
Yes. Share your screen.
Okay. Now, how do I go about that?
Yeah, you go below there. There's a kind of a square box with an arrow pointing up. That's your square screen icon.
Yes.
That's the one. Click on it. And then after that, you click on it. There's another share screen icon. You press on it. Click on it also. That's it. We can see it. Yeah, we can see it now.
Okay. Now, this is one of my favorites as usual, Omega Centauri. Let's see now. And this picture is taken by an Italian guy, Massimo Di Fusco, with advice from his friend Mirko Turra. I'll tell you a bit more about them. But first of all, let's just appreciate this. It's really, really wonderful, isn't it? Just look at it. One of my favorite objects in the sky. If you're lucky, you can even see it with the naked eye, just like a bit of cotton wool, a faint star. If you have binoculars, you can see even something better. Large binoculars will resolve some of the stars in the outer edges. You have a 4-inch refractor and above, and you really see a wonderful sight. Of course, if you are into astrophotography, even with a smart telescope or with the ordinary, with the more sophisticated setups, you can see something really like this.
Yes.
Now, this is a globular cluster. All right. Now, before going there, let's give credit where it's due to. Now, this guy, Massimo Di Fusco, was born in 1983. He really loves astronomy. He's a chemist. He only started very recently. If you look at his timing, it's 2020, he started taking planetary photographs. 2021, he started deep sky, and just look at what he's able to get. Something like this in just about a few short years. Okay. Now, it's very interesting. I tried to see how could he get this. Did he take the picture from NASA and then process it, or did he take it himself? Now, it's interesting because this is the equipment that he used. A 20-inch Newtonian f3.6 with this monochrome CCD camera with the equatorial mount. He used filters to get the colors, and in software and 2024. Now, how did he get all this? Because he used the Chile scope, which is a remote telescope observatory in Chile. I looked it up. You can actually go and sign in, pay your fees, and you can book a session there. They got 3 telescopes for you to use, and they guide you through what are the parameters you want to input, what are the objects that you can see. book your time and start imaging, and download the image onto your computer, and then you can process it and get something like this. So it's quite interesting how they go about it, and how this actually enabled people from the northern hemisphere to see what's going on in the southern hemisphere in real time. Okay? So that's how he got this picture, but still full credit to him because it's an incredible picture. Okay?
Yeah.
Now, globular clusters are quite interesting. First of all, of course, they're globular. They're spherical collections of stars, hundreds, thousands, hundreds and tens of thousands, 100,000 stars, all packed into a very small space. Okay. Now, just within a few tens of parsecs, so maybe a few 20 light years across or something like that. Now, initially it was thought that, oh, with so many stars, they must be full of planets. They must be full of civilizations there. But surprisingly, the latest theory is that they are quite planet-free. Okay, they are very free of gas. The stars there are majority type 2 population stars. That means they are from the early days, helium, hydrogen, that's about it. They don't have any of the heavier metals, past maybe helium and so on. They don't have very much to see. So to make planets, you need dust, you need gas, you need heavy metals to actually form planetary systems. So it's not surprising that they are quite rare, that planetary systems are quite low in globular clusters. Plus, of course, the fact that they're all packed together, can you imagine the orbital dynamics that goes on around there? Any planet which is liable to form will be just torn apart by the thing. And in this respect, it's quite interesting because if you watch Netflix now, there's the movie adaptation of the three-body problem. And it's going on right now, and you can understand, even with 3 stars, they're finding it so difficult to get a stable orbital configuration for civilization to survive. What more if you're in the middle of something like this?
Fantastic.
And I remember there's another short story by Isaac Asimov, or was it Arthur C. Clarke? Nightfall.
Yes.
Yes, and after all the moons have eclipsed all the suns, the 3 main suns, they realize they are in the middle of a cluster of millions and millions of stars which shine down upon them and literally drive the population insane. So it's quite interesting, globular clusters. I always had a soft spot for them. Now, there's something special about Omega Centauri. Now, it's located fairly near. It's the largest and most luminous globular cluster in the Milky Way. It's massive. It's massive and so large that under a good dark sky, really, really dark with good eyesight, you may be able to see it as a faint scuzzy star. In fact, some say you can even see it as big as a full moon itself in really, really good conditions. So if you can look up on the net, it's very interesting to see the size of Omega Centauri compared to a normal globular cluster. It is huge. It is really huge. Okay? And unlike other globular clusters where the stars are more uniform, they sort of all form at the same time and, they're the same age. In Omega Centauri, there's a lot of diversity in the star population. They got blues, they got blue stars, blue giant, blue stragglers, they got yellow stars, they got even red giants. So it's a diverse population of stars. And what else about that? The other thing about Omega Centauri is, of course, understood that with diverged population of stars, with different ages of stars, you also have different types of elements, different bearings levels like iron. So they're fairly a significant, small but significant amount of heavy metals. And the latest study says, by looking at the orbital speeds at which stars move around the cluster, they feel there's something anchoring this globular cluster together. And the suspect is, of course, as usual, a black hole. So all this doesn't fit in with the normal, typical globular cluster. So much so that nowadays they say that suggested that Omega Centauri may not be a true globular cluster, but rather a dwarf galaxy which has been disrupted and absorbed by the Milky Way. All the arms have gone, all the surrounding stars have gone into the Milky Way, leaving behind the core of the dwarf galaxy, and that is the Omega Centauri. It's been postulated that a quarter of the globular cluster population may have been formed in this way in the Milky Way, and in fact, more than 60% of the globular clusters in the outer halo of Andromeda is actually formed by cannibalization of dwarf galaxies. So to sum up, NGC 5139, 15,000 light years away, 10 million stars, okay, within a volume of 150 light years in diameter. Largest, the brightest, and it's quite interesting because it exhibits different star population, different ages, different chemical distinct. And we are lucky at the equator, we can see it with a telescope. Guys in the northern hemisphere have to make do with saying that, oh, the Hercules globular cluster is the best.
Come to Malaysia.
yeah, that's right. Come to us. Okay, and so I'll leave you with just one last look at this.
Cool.
And, okay, now this is incredible. In fact, it's so nice that I feel that maybe we should explore, as an association, we should explore remote telescoping for our group and maybe see whether we can get preferential rates to book telescopes for the society. Okay, thank you. That's on the first presentation. Now my second one is on, excuse me, sorry.
27th of March.
Yes, 27. Okay, yes. Share the screen.
Yes, can see now.
Okay.
Yes, can see.
All right. Not clear it slowly now.
Can see?
Okay. Now, can you see, is it an entire screen or?
I can see the wording on the right, and on the left are the smaller pages. You maybe click on the picture.
All right.
Yeah. There you are. Can see?
Okay. Now, the Coma cluster of galaxies. Again, to give credit where this is due to this made for a guy named Joe Hua. And now he's also a pretty interesting this thing. Scuba diver, underwater photographer. If you go to his webpage, he's got some very nice movies about groupers, a giant octopus, and so on. And I used to wonder, how did he get this? This is incredible. I don't think it's just taking a picture off the net and then processing it and putting it at his own. So he's got a group of friends, and they own and operate a remote observatory in Texas. And he uses this Astrotech RC8 carbon fiber tube. And this, it's got a camera, it's got a huge thing. If you see the picture and you said, it looks impressive. Really huge telescope there. And it's not surprising that I guess eventually they're able to get something like this.
Yes.
Now, every single object in this picture is a galaxy. Can you imagine that? And every galaxy is hundreds and thousands, millions of stars. Can you imagine the number of stars in this picture alone? Now, this coma cluster of galaxies forms the coma supercluster. And it's supposed to be a textbook example of a cluster, a galactic cluster. Thousands of identified galaxies. There may be much more, up to about 10,000. The most prominent are these two, NGC 4889 and NGC 4874, giant elliptical galaxies that dominate the core. Okay. Now, apart from the wonder of it, apart from just looking at it and imagining the number of stars, the number of potential planets, the number of potential civilizations that are there, this is actually a celestial laboratory for observers on Earth. Because the interaction of all these galaxies together, the gravitational pull they have on each other, the X-ray sources that arise from here, the radiation that comes out of this entire thing, is actually a celestial lab made just for observers on Earth. Okay, and it's the closest and most richly studied group of galaxies because it's got hot X-ray emitting gas sources. It's got dark matter, which they have managed to postulate from the orbital and the galactic, the gravitational disturbances within the cluster of galaxies. You can see evolution of galaxies in different forms. You can see the shape of galaxies which have undergone interaction with each other. So much so that they say that most of the galaxies here are elliptical rather than spiral. Saying that, okay, all these are the aftermath of tidal forces that have ripped spiral galaxies apart, torn away the arms and left you with all this. There are, of course, a few spiral galaxies probably that's edge on there and there, but the majority are a significant number are elliptical galaxies. And so apart from just the wonder of it, this is actually a very rich source of research for astronomers at the moment. They use all kinds, especially now with all the latest telescopes concentrated over there to get research being done. And a short look at it one more time now. I've just rotated it so you can get a full panoramic view of it. And imagine this picture being taken by this guy. Just look. Oh.
Amateur astronomer. Oh.
Yes. The picture of his equipment is incredible. It's there on the net. If you have a chance, go and take a look at it. It's wonderful. This is really, really, really great. Okay. Now, this is the coma thing, and the next one is
24th of March.
24th of March. Also very nice one. Now I shall. Now this is a very interesting picture. We probably can you all see this, please? Can you
24th of March. This is still the previous one. 37, 24th now.
Now? Not yet.
No.
Okay. Let me just get this going.
Looking back at the eclipse Earth
Yes.
Yes.
Now, can you see that?
Yes.
Okay, now looking back at an eclipse Earth. Now, this is a photograph which is really fascinating. We'll probably never be able to see this at all. I don't think anyone on Earth will be able to ever see this again. This kind of picture, because what you're looking at is, and okay, it's taken by the May 27 crew, to give them credit, and I'll talk to you a bit more about these people. But first, let's just appreciate this picture.
Fantastic.
Isn't it wonderful? Isn't it wonderful? Huh? Oh my God. An eclipse of the sun by the moon, with the moon's shadow falling on Earth. Actually falling there for you to see. And you'll never be able to get this except unless you're above in orbit of the Earth, looking down to actually see where the shadow is. Now I remember using my Dobsonian and looking at the shadow of Jupiter's moons on the surface of Jupiter, and feeling so thrilled about it. And just look at this, the shadow of the moon on Earth. Okay. Now, apart from this picture, which I'll talk to you about later very shortly, but I think I would also be interested in talking to you about this. Mir. I remember when those days, I remember Mir. It was the first real space station up there in the sky. You know, I remember Mir when I was in younger times at the Institute of Astronomy, and he talked about Mir police station, space station, and all the salutes that went up. It was launched in April 1971, and finally burnt up when it got deorbited and entered the atmosphere in March 23, 2001, and burnt up. 15-year mission. And it had a lot of benefits. Scientists learned a lot about it. And it's actually the forerunner to the International Space Station now. It was modular. They just added salute spacecrafts here and there, and they connected it all up together. Now, it is the May 27th of the 27th, this thing, mission up there, put by a 3-man team who actually took this picture, one of them. One Russian, one French, and one Czechoslovakian guy. Because they sold the seats. They actually were running on a budget. They needed money. The Russians needed money to fund their program, and they sold the seats to these 2 guys. And these were the 3 of them who went up there. And in case you're thinking it, oh, Mir must have been some very small time stuff, just look at a picture of it.
Big, it's huge.
Nice. Look at that. All the salutes used to spacecraft to come, and this was the core of it, this long thing. And the salutes used to come and dock there, and so on. And even I think in the final stages, when America had their space shuttle, they also came and brought a docking pod to be put here. Now, it's different from Space Lab. Space Lab was nothing much. It was just the cargo hold of the space shuttle modified so that you could stay there without a spacesuit and do some experiments. That was Space Lab. This was the first genuine orbiting space station. Okay. Pity it's gone. Pity that Russia's not in the space program anymore. It had learned a lot, but anyway. Now, coming back to this eclipse. Now, during a solar eclipse, the moon shadow is the umbra. It's only about 300 miles wide, where it's completely blocked. Okay. And penumbra, where the sun is the same, I think it can go up to almost 600 kilometers. Now, this is what is the umbra. And if you are staying here, you'll be able to see a total eclipse of the sun. Now, the sun stays behind the moon for a very short while, a few minutes. But because the Earth rotates so fast in that short period of time, the shadow moves across a wide area, and a lot of people are able to see an eclipse of the sun in that short time. Okay, and you can see almost 1/3 of the way around the Earth's surface will be able to appreciate the shadow and see the eclipse of the sun, of the moon. But rather, sorry, eclipse of the sun. Okay. And everyone's looking forward to this. 2024 in America, US, and Canada. Well, they're all going to see a total eclipse, solar eclipse. And remember this thing, okay? And I think, if I'm not mistaken, these two are the planets Jupiter and Saturn. I'm not too sure.
Yes.
See, which can be seen in space. Okay. Now, hope we all appreciate this. This photograph is incredible, and the science behind it, of course, the sun or the shadow of the moon falling at that spot in that place, and the Earth rotating, bringing different parts of the Earth under the shadow. And the shadow lasts for a short while, so the Earth better move fast enough so that enough people are brought under the shadow to appreciate the eclipse. And then, of course, the sun moves away and the eclipse over. Now, why don't we get an eclipse of the moon every time we go around? Because the orbit of the Earth, of the moon, is tilted. And although we go around, the moon goes around the Earth, it goes at an angle to the sun, so that sometimes it goes above the plane of the sun's orbit, so it doesn't block the sun. Sometimes it goes below the plane of the orbit, and only once in a while does it go exactly in front of the sun. And when that happens, you get this. Right? Okay, thank you. Then.
Yeah. So those of you still got time. Let's go to USA, 8th of April. I'm sure the Americans, the Mexicans, and the Canadians are all waiting for good weather. Yeah.
Recently, there was a few articles on in BBC and also in the New York Times about eclipse burns.
Yes.
A number of people who have looked at the sun with their naked eye and with defective eclipse spectacles, which they bought just off the road, of the thing, and they've actually got burns in their retina. Which some recovered after a year, some were permanent burns. So a warning, I guess, that whenever you look at the sun, please be careful.
Yes.
Okay, I think that's about it. I have much to say. Thank you.
Thank you. Okay, let me share my screen. So we go to the next picture, 32nd of March. Okay, here. Okay. You have here, I read, Phobos, one of the moons of Mars, over the Mars. All right. So in other words, Phobos is actually over here. You can see a dot here, and that's Mars. And it's taken, of course, once you see the image credit is NASA and ESA, European Space Agency. And this is Zod Levy, one of the scientists in SCSCI. Of course, SCSCI means Hubble Space Telescope and James Webb Space Telescope. So this is actually taken by Hubble Space Telescope many years ago. And the acknowledgement is the scientists who got the data were Jay Bell from ASU, Arizona State University, and Wu from Space Science Institute. So basically, from Hubble Space Telescope, the research event, they were able to focus on Mars, and then you have the moon of Mars called Phobos. There are two moons of Mars, Phobos and Deimos. So this Phobos, a small asteroid about 11 kilometers in radius, coming out behind the Mars and coming here. So it takes about 13 times, right? And because the Phobos is orbiting Mars very close to the surface of Mars, it's only about 6,000 kilometers from the surface of Mars only. 6,000 kilometers. So therefore, okay, let me click on it. Okay, so you want to see the Phobos? I enlarge it here. There you are. There is Phobos. All right. I go back to the original size for the picture. Okay, so Phobos is coming out, And because Phobos is very close to Mars, Phobos actually orbits the Mars in only about 7 hours. And Mars rotates on its own axis in about 24 hours. So in other words, Phobos will rise in the west and set in the east. Because it orbits the Mars faster than Mars rotates on its own axis. So that's very weird, you know. So on the Earth, for example, the moon moves very slowly, rise in the east, set in the west. But this one, Phobos, rise in the west and set in the east. Okay, and of course we know that Phobos is the Greek for fear. All right. So remember there are two of them, Phobos and Deimos, fear and panic also. But this is fear is there. So we know that because this Phobos is so close to this surface of Mars that it is within the Roche limit of Mars, or something called the Roche limit. All right, the Roche limit discovered by French theoretical physicists that if you can move orbit around a big object, let's say Phobos, which is a solid like an asteroid, orbit around Mars, the what they call within the Roche limit. So the Roche limit is in this case is quite further away from the surface of Mars. So Phobos is inside the Roche limit of Mars. So the gravity of Mars would pull on this what they call Phobos. So on the part of the Phobos is further away from Mars, and the part of Phobos closer to Mars, there's a differential force. And because the differential force is significant within the Roche limit, they will tear and break up this object. So in years to come, not tomorrow, maybe in maybe hundreds of thousands or millions of years, Phobos will be broken up, and then what will happen? There will be a ring around Mars, just like Saturn. The rings of Saturn are because the rings orbit around Saturn within the Roche limit of Saturn. So the same thing as this one, in time to come, so this Phobos will break up and form a ring around Mars. So basically, they call what? The Phobos is a doomed moon. It's doomed already. It will break up soon. But don't worry, our moon, 400,000 kilometers away from the surface of the Earth, is outside the Roche limit of the Earth. So the moon will not break up, right? But in this case, Phobos will break up, all right, in future, all right? And look at the picture of Mars taken by Hubble, beautiful, huh? So I go back to the picture to give the accreditation. So you have, okay, let me see. Yeah, so that's it. So the conclusion here is Phobos is doomed, okay? The next picture, 19th of March. Nice one. So Dr. Jiwa, please pay attention. You can take some picture like this for IPO. That's what my idea is. Okay, so you have here a picturesque equinox sunset. So basically what happened is, in the year 2021, this American astrophotographer, Alan Dyer, he went to Canada in the province of Alberta, right? But he's in Canada, but he's an American guy. And he went to a place where there's a road, a long road that is lying pure east and west, right? And he took it during the time when you have the September, what you call equinox in September. Remember, on September 21st, 22nd, you have the September equinox, autumnal equinox. Whereas on March 21st or 22nd, you have the spring equinox. So in this case, on September equinox in the year 2021, he went to Alberta. There's a long road, east and west, and this is the setting sun, and he took the sun setting over this long road. All right, so it's a picturesque equinox sunset. Remember, equinox here means equal, equi. That means on that day, say 21st of September. All right, that the time for daytime and the time for nighttime anywhere in the world is about the same, all right, or about equal. All right, that's what's called equinox. All right. So this is a case where like this. And by the way, Dr. Yua, many amateurs astronomers in the world, they have took this equinox sunset for many places. One of them is where? Manhattan, New York City. Remember, with all the skyscraper, that some of the roads are lying, say, many kilometers east and west, you know. So they put up the telescope on one part of the avenue, and you look at the other one, the eastern part, of the sunrise, or the sunset during the equinox time. Right, 21st of March or 21st of September. So this is the equinox for a place in Alberta in Canada. All right, taken by Alan Dyer. But let's look at this. I checked already. Now, this is Ipoh, the city of Ipoh. By the way, Ipoh is a city in Peninsular Malaysia. All right. And now I want to enlarge the picture for Ipoh. Let's look at the road there. There are many roads. And then here, there's this road here. I enlarge even further. There you are, this road. Okay. Jalan Sultan Azlan Shah. So this is the part where it joins the Jalan Air Putih, one of the main roads in Ipoh, going roughly north. But this road is actually perfectly aligned east-west. This is about 3.5 kilometers right? But of course, this is the ending part of Jalan Sultan Azlan Shah. But the other part, you stretches here, it goes much longer, but it's not pointing east-west. So this is the part where Jalan Sultan Azlan Shah, where let's say you put your camera right in the center road here on the eastern part, looking at the west for sunset, either in spring equinox or autumnal equinox. Or you put your camera here on the western part, pointing east to look at the sunrise. I think you can take the equinox picture earlier, taken by Alan Dyer. So because you know what, I've been looking for years. There's no road in Georgetown City that points due east-west. KL City also don't have. But Ipoh has this interesting road called Jalan Sultan Azlan Shah. All right? Maybe you may not be able to put your camera too long there because the traffic is moving. Maybe you make sure no cars are coming. Quickly take a picture and run away from the center of the road. So this is a good place, Jalan Sultan Azlan Shah. Okay.
All right.
So now the next picture. (18th of March). We know everyone is keen on this. The comet Ponsbrook. Okay, swirling coma. Okay, so about the person is our Mr. Jan Erik Varestad. Okay, because he's a Norwegian. So Norwegian, the JAN is pronounced as a Jan Erik Varestad. All right, amateur astrophotographer. So he took this page, this comet. Remember, Ponsbrook is now still about naked eye visibility. You can do it. So now, by the way, Dr. Jibarak, many people in America are waiting to see Ponsbrook during the total solar eclipse, 8th of April. So when the moon covers the sun, maybe the comet should be visible, maybe by the naked eye. So that's what they're expecting also. So you see here, the comet. So basically you have the straight tail, the blue tail, which is the ion tail, ION. What is the ion tail? You have the solar wind of the particles of the sun. The solar wind particles of the sun are the electrons and the ions, IONS. They are the elements with electrons stripped from it. But they travel very fast and they will knock at the particles from the nucleus of the comet, which are evaporated off, and to form the coma. And the solar wind particles will hit this what they call particles from the nucleus, and you form a straight tail, the ion tail, ION, all right? And it's a blue one. And at the same time, the nucleus of the comet is the only part that is solid. The other parts, like in the coma, is just like a vacuum with all the plasma around it. The materials evaporated from the nucleus to form the coma. Now the coma can be quite big, can be up to a few 100,000 kilometers in diameter. And then you have a tail here. Now, some of the comet tails can be, go back again. Some of the comet tails can be up to tens of millions of kilometers long, right? So you have this ion tail here, and then because the solid part of the nucleus is rotating, so it's a swirling. You form this part swirling, the red part, and also you have the other coma, which is green. Now green because we know that the nucleus of the comet have this diatomic carbon, C2. It's a kind of a molecule that has two carbon atoms connected by covalent bond. and it gives off green light. So this is comet Pons-Brook. All right. Okay. And then of course this is will be soon. There will be the total solar eclipse in about a week's time in America. So everyone is hoping to see this comet during the eclipse. Let's see. Okay. And you see here a lot of other stars in the background. Okay. So I stop my presentation now. So I pass to Yongli.
Okay, thank you, Dr. Chong.
Okay. Yeah.
Okay, can you see my screen?
Yes, I can see now. You can see now.
Okay. Okay. I'm going to present the pictures for 16, 14, 12, and 11th of March. So today we'll the theme is about the phenomena of light. So the first picture is taken on March 16th. So let's have a look. So this is a picture. This picture is about the largest optical telescope in the world. So this is ELT, known as extremely large telescope. So astronomers are actually quite descriptive in their naming. So whatever the thing is, they'll name it just as it is. So initially it was named EELT, European Extremely Large Telescope. So this is currently the largest optical telescope in the world. But the largest telescope is of course not this one. The largest telescope in the world is the one. Oh no, I'm still presenting the same one. Oh, sorry. So okay. So here is, so this is the landscape of ELT, the night sky. So you can see the Milky Way, which is very beautiful over here.
Yes, Yongli. Continue. Continue, Yongli.
Yeah. Okay. Thank you, Michael. Okay. So so this is the landscape you can see. Besides that, you can also see the two satellite galaxy we have, which is the Large and Small Magellanic Cloud. So if you look at your the star chart over here, and you go to the South Circumpolar region, you can see the Large and Small Magellanic Cloud near the Dorado constellation, and Hydrus constellation. So the extremely large telescope. So it is the largest optical telescope we currently have. But of course the biggest telescope is in the world is currently held by the radio telescope, which is the one in China. So, but for optical, 39, this is the largest. So the size is 39.3 meters wide, and it is made out of 798 mirrors joined together. Because when you have a big mirror like this, it's very heavy. So it's impossible to have one continuous parabolic mirror. So the ELT is currently still under construction, and the primary mirror is a segment made of segmented mirrors, and the total diameter is 39.3 meters. So it will be the largest optical telescope ever built. And this ELT, there's another feature that makes it quite unique. It has adaptive optics. This adaptive optics will be able to compensate for the turbulence of the sky in the desert. Not that there's many to begin with, but plus the adaptive optics, the resolution of the images taken by ELT can be improved even more until the limits allowed by the Rayleigh's criterion. So according to an astronomer, the resolution of the ELT will actually be higher than the James Webb Space Telescope, which is in space right now. So of course the cost for this telescope will be much higher than the space telescope. So so this telescope is built at one of the driest place on Earth, so at the Atacama Desert, Chile, and it is close to this telescope. You can find the Very Large Telescope. So this is the thing I like about astronomers. They name things very straightforward. So if it's very large, so they name it Very Large Telescope. So it is comprised of 4 8.2 primary mirror telescopes, and it uses the optical interferometry to combine the wavefront of light to produce a virtual telescope pointing at the sky. So it will be essentially a dish which is much bigger than 8.2 meters. So they are able to expand the size of the telescope by using optical interferometry. So usually interferometry is more common in radio astronomy, but according to the properties of light, it can also be done with using visible light. But your computer must be for visible light. It is more the wavelength of light is much shorter. So you need to the time scale you need to be right is very critical. So you need a very powerful supercomputer to be able to do those calculations and make the math to add up the wavefront. But currently it's still possible to do it like this. But in the future, when the technology is advanced enough, we can have many mirrors separated by huge distances. Where when computers are fast enough and cheap enough, we can build many telescopes around many optical telescopes around the Earth and create a virtual telescopes which is much bigger than the ELT, because ELT is only is a single dish mirror. So this to build one single large dish is much more expensive than having a few mirrors and you do optical interferometry with it. So because this ELT, the technology is at the limit of human capability. So this will probably be the largest telescope that will ever be built up. But if you want any larger telescopes, it will probably be something like this, the optical interferometers one.
Okay.
Okay. Next, I'll talk about March the 14th. So this is an image of the moon and the shadow of the mountain. So what is so special about March 14th? So March 14th is actually if you write it down, it's actually 3.14. So this day is known as Pi Day. Pi Day as in 3.14. So so NASA on this day, NASA likes to share some related facts in astronomy to Pi, which is the full moon. So you can ask, what does a full moon has anything to do with Pi? So this is taken in the Teeter Observatory. So this is the observatory. So you can see the white spots over here. This is the Teeter Observatory.
Wow.
And this is taken at Teeter National Park. So Pi Day, this 3.14, this is taken on 2020 and the 9th of March. So full moon means the Earth is the moon relative to the Earth is pi radians away from the sun. So pi radians, according to mathematics, is exactly 180 degrees. So on the moon we'll be able to see the full the full reflection of the Earth, the moon onto the Earth. So and the moon you can see is quite close to the horizon, so it's slightly orange and flattened. So the shadow over here is actually is quite a high mountain. It's the Teeter volcano peak, which is 3,500 meters above the sea level. So it is only 500 meters lower than our Mount Kinabalu. So the next picture. So on the March of 12th, there's a mysterious object over here. So can you explain what is this? So over here, it looks like there's a spiral galaxy spotted on the Earth, but it's very weird. So what kind of phenomena is what is happening over here? So you can have a guess. So, but besides that, you can also see beautiful aurora in the snow. So this is near the northern part of the sky. So unfortunately, this is not a natural phenomena. It's actually a man-made phenomena, but it's mixed with some physics. So this is actually the rocket exhaust produced by Falcon 9 rocket. So on the 4th of March, there's a rocket launched by SpaceX at the Vandenberg Space Force Base at California. So this the launch of this rocket causes the exhaust left by the rocket leave behind this kind of effect, which is known as the twilight effect, and I'll explain it later. And this is taken at Akureyri in Iceland. And this Falcon 9 rocket is was carrying the Starlink payload. So it will attempt to launch another rocket today. I think there will be another launch of the Falcon 9 rocket. So the twilight effect. So the twilight effect is actually a man-made phenomena, which happens when you launch the rocket at a specific time. So if you launch a rocket is launched around 30 minutes before the sunset, or 30 minutes after the sunset, sunrise 30 minutes before sunrise or 30 minutes after sunset, you can actually see this phenomena. So the definition of night means we are entering the shadow of the umbral shadow of the earth. So we are on the surface of the earth, we are under the shadow, so it is nighttime. But if you launch something to launch something high enough, it can relative to the rocket, the it can still receive some of the sunlight that hasn't set yet. So to the rocket, the sunlight may not have set yet. So when it launched to the sky, it will produce it will leave behind some of these exhaust fumes. So these fumes will actually expand due to when you go to higher atmosphere, the gas will expand due to the ideal gas law. Due to because you have a lower pressure at the higher atmosphere, it will leave behind this kind of gas trail, this expansion of gas. and this gas will at the same time be illuminated by the sun, our sun. So it is the twilight of the sun, the leftover light from the sun, reflecting back at the sun. So on that day, Falcon 9 is reorienting its rocket, so you can see the spiral effect caused by the Falcon 9 launch. So for March the 11th, let's have a look at this image, the full plankton moon. So this is also taken by Patrick Horalick, as Dr. Zhang mentioned just now. He's the Czechoslovakia astrophotographer. So this is a huge image. So I'll share it on the website. So this is a 2-in-1 picture. So on the sky, you can see the composite image of a few full moon. The full moon is setting, but on the surface you can also see a beautiful effect known as the blue tear. So you can see the blue tears on the beach. So zoom out. So this is, I like this picture because it contains two very interesting phenomena of light in one picture. So the first one is the scattering of light due to our atmosphere or the aerosols on the Earth. So you can see the transformation of the moon when it sets. It changes from the white moon to the white full moon to a reddish full moon. The second one is called the chemiluminescence or bioluminescence, produced by the plankton or plankton in the sea. So let's first discuss this Rayleigh scattering. So as we know, the blue sky of the Earth is due to the Rayleigh scattering of the Earth on on sunlight. So the sunlight, the white light of the sun will be scattered. So when it is scattered, the effect we see is a bluish sky during the day. So the scattering of light due to our atmosphere is happens when because we have dust and molecules on the surface of the Earth, which is about 1/15 the size of the wavelength of light. So when you have these scatterers, this light will scatter light. So the probability of the scattering is actually proportional to the wavelength to the fourth power. So it means the shorter the wavelength of light, the higher the probability for the light to be scattered or for the light to reach your eyes. So because the wavelength of blue light, which is 470 about 470 nanometers, and the wavelength of red is about 700 nanometers. So when you take it to the fourth power, it is about blue light is actually 5 times more likely to be scattered into your eyes. So that's why the during the day the sky looks bluish. But there's actually a separate phenomena over here, which is also due to the same phenomena, same physics, which is when you have. So I have an imaginary sphere known as the celestial sphere over here. So when you look at the sky above your head, the distance from your head, from your eyes to the zenith is much shorter than if you look horizontally. So the light over here has more distance to it needs to travel before it reaches your eye. So the light over here will be scattered so many times that most of the blue light will be exhausted. So when you have initially you have white light, so you keep subtracting. You can subtract blue. You keep subtracting away the blue light, and then you subtract the yellow light. So it becomes over here you subtract the blue light, it becomes quite yellowish. So the more you scatter, the less of the remaining you have.
Yes.
So it becomes quite a reddish moon over here. So that's why the sunset appears to be red during sunset. So this is the same for the moon. So the other effect is bioluminescence. So bioluminescence is quite an interesting phenomena. You can see on even in Malaysia at Pulau Sembilan and Kuala Selangor. So if you have the opportunity, you can go to these two islands, these two places to have a look at this wonderful phenomena. So this is actually a 3-in-1 physics, chemistry and biology all combined together. So this bioluminescence is produced by this plankton, which is a microscopic organism that produce light to ward off predators. So these planktons will produce through a chemical reaction. It will produce this light known as fluorescence light. So this is due to the chemistry of different molecules. So when you have different molecules having chemical reaction, it will produce this kind of light. But the most fundamental phenomena you can only explain through quantum mechanics. So let's have a look at a simple energy diagram over here. So you have the ground state of the atom and the excited state. So when you have two chemicals react with each other, one of them may produce UV light. So this UV light will be used to excite the electron from the ground state to the excited state. The excited state is causes the molecule to become very unstable. So eventually it will decay and release some of the energy. But eventually it will fall from the excited state back to the ground state. And if you calculate the difference of the energy, it is actually within the visible spectrum, which is blue. So the color you see for these planktons are bluish, which is quite beautiful. So I have a few minutes. I can show you
Sure.
the image of the blue tears. Very, very beautiful. So this is the beach. You can see they're playing with the plankton water, with the blue tears. Very beautiful. Wonderful phenomena. You can see even in Malaysia. Okay, that's all for my presentation. So I'll give it to Dr. Jiva. Thank you.
Okay. Just a question. This are we able to see the small and large Magellanic clouds from where we are? Notice you said it's around the constellation Dorado.
It is quite close to the southern sky. So I don't think we can see according to our the I think the limits for the limits for Malaysia, I'm not sure. I don't think you can see Malaysia.
Because I remember seeing it when I went to Australia.
Yeah, it's the constellation the galaxy you can see on the southern hemisphere, right?
Yes.
Yeah.
But I don't know how many degrees above the horizon it is.
It is it's minus 70 and about minus 75.
Actually, we can see it from as north as Penang, no problem.
Yeah, from Langkawi, easily you can see large and small Magellanic cloud.
Oh, is it?
10 degrees.
Langkawi can see easily.
Langkawi, yeah.
Langkawi is very far north. Further north than Penang, Langkawi can easily.
Oh yeah, yes, correct.
SMC is much higher, about 20, 30 degrees.
Yeah.
Okay, thank you.
So Jiva?
Okay, let me see now. I am to give.
So Michael, I will go faster when it comes to me. Okay.
Okay, number 17. Let me see. Sorry, guys.
Yeah, 17th of
Okay.
March.
All right. Mm-hmm. Okay. Now this is NGC 7714 starburst after a galaxy collision. Can you all see it?
Yes.
Okay. Yeah. Incredible, isn't it? Oh.
Yes. The picture, please. Waiting for the picture.
Okay. Let me see. Now?
Yes.
Okay. I'll just
reminds me of the antenna, but it's not the antenna.
Yes, not the antenna galaxy. Can you see it now?
Yes.
Now, this is actually supposed to be known as the Ring of Fire galaxy in the constellation Pisces, and it's definitely an irregular galaxy, no proper shape and so on, and it's postulated and it's also well known for its intense star formation activity, and you find this hot young or active stars in a row. You find a disk or halo of yellowish stars here and a center of white intense hot star forming activity, and this disrupted arms which are going here. So it's been postulated that there's a galaxy here which is actually rammed through a spiral galaxy, and there's a collision of two galaxies that's going on here. So you have a striking ring of bright young stars encircling the galactic core, which is a ring of fire. And this due to a violent distinct. Okay? Now, when we talk about collisions and this thing, we usually think of destruction, things dying, things running out, and so on. But in the universe, it's not always like that. And in fact, every collision, every destruction doesn't mean that there's ending of things, but rather there's also the formation of new things. All right, and so apart from the old yellow stars and the thing which are there, you'll find intense star formation over here, because the disruption as the galaxies pass each other causes collision among the gases, and the nebula causes stars to heat up and the gas to heat up and then coalesce and form new stars, right? And it's been postulated that this interaction between these two the galaxies actually occurred about 150 million years ago, and it's probably going to go on for many million years on and form even new stars which are able of giving life or supporting new life and new planets. Okay, so once again, this is a celestial lab for all the telescopes on Earth, for all the astrophysicists on Earth who have been studying this with various wavelengths, from X-ray to radio wavelengths to optical light, and even with the James Webb telescope within the infrared. Now, if you look at the papers on the web, if you were to go and look up this NGC 7741 and click on the links and so on, it'll actually lead to many scientific papers put up by these astrophysicists on the various processes that seem to be going on in this Ring of Fire galaxy. And the conclusion that we can all safely say is that the universe beyond us, collisions among giants doesn't mean the death and destruction, but also the opportunity for new life and star formation. It is a beautiful picture of that, and illustrates very clearly that every time something ends, there's also a new beginning for all these stars. That's on the starburst after galaxy collision. And my last one would be on sorry, not that.
The 10th of March.
Yes, the 10th of March.
The 9th of March.
Okay. Now, once again, Comet Pons-Brooks, and once again, our friend Peter Horolek, who said,
Please
"Think
post the picture. Please post the picture.
Yes, this one. It's beautiful. Can you see it now?
No?
Sorry.
This Patrick Horolek is so
the box. The box. Yes, now can see.
All right, this one and Peter Horolek
Again,
and
fantastic.
And he's got 3 pictures already in just this month's APOD.
Yeah.
Thing, and he's a such astronomer, physicist, a freelance photographer and portrait astronomer. He's a winner of several NASA Picture of the Award, the first SEC ambassador for European South Observatory, popularizer of astronomy, writer, traveler, lover, and photographer of the night sky. He's actually born in a place which is near an astronomy center. And then there's an observatory there. And so he really just fell into astronomy right from the word go. And this is one of the most beautiful pictures I've seen. Really, really nice. Just look at that. Incredible, incredible. Andromeda, there's a star there. And there's the comet there. And there's mist. The shadow of the trees is blue. It's really a beautiful picture. Now, Dr. Chong has already told you a bit about Pons-Brooks. Basically, it's a comet discovered by Jean-Louis Pons and William Robert Brooks in the 19th century. It's a periodic comet known as the heli-type comets. Long periods of return, and known for going right out to the outer reaches of the solar system around Neptune and above, and then coming back again into the Earth's orbit. And its orbital period is about 71 years, while Halley's is about 76 years. And you all know about the coma. Dr. Chang has told you about that, and the tails. But just look at the beauty of this picture. It's really, really, really beautiful. And so what you can see
to me, it looks also like a haunting picture.
Yes.
Like a mysterious haunting picture, but nice.
Very nice. Very, very nice picture. And you can see the green coma, the long tail, and it's photographed in Slovakia on March the 5th. The M31 and the yellow star, one of the belonging to the constellation Andromeda there. Really, really, really nice. Beautiful. And for those who are interested, well, Pons-Brooks is in the constellation Aries. And I think it should be even better visible in about a few days time in April, a few weeks time. And if you can't see it, well, maybe we should be able to capture it with our smart telescopes. You take one look at it before it comes again in about another 71 years. So that's my take on this one. I just leave you with this picture.
Really nice.
This one, it's beautiful.
Wonderful.
Wonderful, wonderful, wonderful picture. Okay, thank you. That's all for me today.
Yeah. Thank you, Dr. Shiva.
Thank you.
So I go to my next picture, 10th of March. I read out the caption first. All right. A total eclipse at the end of the world. By the way, gentlemen, this is, I think, the third or fourth time they put in APOD, you know. This picture came out quite, I think, a few times already. So I will make it smaller, but it's okay. Okay, so basically, this guy, Mr. Fred Bunyas, is an American amateur astronomer from Missouri, traveled to Antarctica, right, on 23rd November 2003, 21 years ago. So he must have spent an amount. That means he went to not at the exact South Pole, but close to the South Pole, 23rd November. So that was the southern summer. And it occurred a total solar eclipse. And when you have the solar eclipse, you see the total shadow of the moon here. You can see the corona, but at the horizon, at the rising sun, at the horizon. And as I said, this being in the close to the South Pole, the sun and the moon do not rise from below the ice up. It goes parallel, more or less parallel to the surface of the horizon, right? And just another guy also was there. So Fred Brunis was the guy taking the picture. The other guy was there with his camera equipment, and just at the same time, they took a picture of that guy, human being, with the eclipse sun and the moon. So nice, all right. So this is our total eclipse of the sun, of the sun at the end of the world, all right, on the 23rd November 2003. Okay, now we go to the next one, 7th of March. That's interesting. This similar to what Yongli said just now. Crew 8 Nebula. Remember, you have this space Falcon 9. SpaceX want to launch another mission on the 3rd of March, already launched to the space station and launched successfully. So what happened is this guy, Michael Seeley, American photographer, he specializes in space launches, and he took this picture. This is not a nebula. This is the exhaust from the Falcon 9X as it goes up into space. And so as it goes out to space, this is the first stage. The exhaust, after being launched to space, the first stage will land again and will be reused. And then as it comes down, it will be spiraling, and you see this spiral exhaust gas. This is not a nebula, spiral exhaust gas of Falcon 9. The launch, the Crew 8 to the ISS. And here also, there are a few of the American astronauts and one Russian cosmonaut joined the ISS. Remember, the ISS will have a shift. They work shift, every 6 months. Every 6 months, there's a change of shift. So recently, on the 3rd of March, change of shift. So now the crew, what they call 7 space crew will come down, and the Crew 8 will remain in the ISS. Okay, and this was taken by Michael Seeley, okay, American space launch photographer. Next picture is the 4th of March. This is interesting. Oh, what is this? See, the light pillars over Inner Mongolia. Remember, you have China, and on top of China is a big country called Mongolia. But between Mongolia and the Beijing, there's a part of China called Inner Mongolia, part of a big province of China. So basically, this is a light pillar. And what happens is this guy, Chinese photographer Andy Liao, went to Inner Mongolia. And what happens is that there's a kind of some town or what they call beyond the horizon that gives off the street light or whatever light. And this is very cold at that time. And the light will scatter off the ice crystals that are in the lower atmosphere. And the color light of the street light will hit the flat ice crystal and scatter back to the earth. So this is a light pillar of the lights of that town beyond the horizon. And this place in Mongolia is called the Wulan grasslands. All right, but of course, in astronomy, you've seen a lot called what sun pillar also. I mean, beyond the horizon is the sun, and you have some very bright pillar called the sun pillar. But this is not. This is a light pillar of some of the street lights, the lights on the ground, coming out from those lights and scatter off those black crystals and coming back to the earth. And you can see some of the constellations behind that. And right over here on the top left hand side, you have the star Polaris, the pole star. Very nice, huh? So the light pillar over Inner Mongolia, 2nd of March. This is interesting. Now, this is, this is a mission that 50% succeeded or not fully succeeded. So remember, NASA has left the moon on the Apollo 17, all right, 1972. So this is the first time that Americans went to the moon with a lander, and it's by a company called Intuitive Machine. And the lander was this object called Odysseus, all right, landed on the moon. But something happened during landing, and one of the legs broke off, and it landed and tilted like awkwardly. So it didn't stand up upright on the moon surface, but tilted tremendously. So it cannot take a lot of data, right? So this is Odysseus spacecraft on the moon by this Intuitive Machine company, and this spacecraft is called Nova C Moon Lander, all right? And this one landed surprisingly just close to the south pole of the moon, only 300 kilometers north of the south pole. All right? Remember, was it last year? The India also landed a spacecraft close to the southern region of the moon, but this is even closer to the south pole of the moon by Intuitive Machine company, and it's called Odysseus. This is a moon mission. We go to the 1st of March. Again, Odysseus. All right? And you say, where's Odysseus? No, Odysseus is over there on the moon. This is the moon. But basically, already here, Odysseus and the dish. The dish is, of course, here, a big, fully steerable parabolic radio telescope in Parkes, in northern New South Wales. All right? I've been near there before. So here you have a fully steerable 64-meter diameter parabolic dish in Australia, and we're looking at the moon. Now, remember, when the moon, Apollo 11 landed on the moon, the other radio telescope on the Earth was not able to access to the moon from the Apollo lander, except for this one, Parkes telescope in New South Wales in Australia. So this was the radio dish in 1969 that could receive the Neil Armstrong's image and the sound back to the Earth, received in Parkes, and then sent back to the White House in USA, and President Nixon spoke to the Neil Armstrong, all right, on the moon. So this is our Odysseus, the recent moon landing, which didn't succeed totally, and together with the dish. The dish was the radio telescope that received the moon landing, and that was that you can look at this movie. I don't know, Dr. Jiva, you have seen the dish. Is called the dish. On the time when it landed, and there was some American radio astronomer there and received the signal from Neil Armstrong. Very interesting. And this is taken by John Sarkisian, one of the astronomers working in this radio telescope called the Parkes 64-meter radio telescope in New South Wales in Australia. Okay, so that's all for me. Okay, so I go back to the presentation. So anyone here got any comments? Yonglip, Dr. Jiva? Any comments, questions in the Facebook or the or YouTube? Check. Oh, okay. So maybe Michael. Thanks, Michael, for hosting the presentation tonight, and maybe we have
thank you, Michael.
A bit of chit chat before we stop. Thank you, Michael.
Mm-hmm.
Yeah.